Hello again everyone, welcome back to ptet.chemistry channel. So this is a continuation of this year 11 combined science revision, which is on atomic structure, linking back to bonding and then connecting to periodic table, which contains the metals, the non-metals, as well as atmospheric and environmental chemistry. So let's get started on this thing. So this is completing the sentences. So fill in the blank. You will see that this is a 4-mark question. So this is around 1, 2, 3, 4, 5 there. So one of these must be worth 1 mark, around 1 mark each. So we know periodic table lists the elements. How are the elements listed? In order of, that is in order of protons, or you can say atomic number. Choose whichever one, but these things are given in a periodic table. You will see element number 1 is, well, hydrogen, element number 2 is helium, number 3 is lithium, and so on and so forth, because they have different atomic number, go from 1, 2, 3, 4, etc., etc. Now, what is found on the left-hand side and what is found on the right-hand side, this should be something you know in terms of metallic as well as non-metallic, because the metals are what you would describe as a group 1, 2, and 3, and the non-metals are basically your group 4, 5, 6, 7, and 8. But group 8 is fully filled outer shell, so fully filled outermost, or I used in the last tutorial, I used the term valence shell. So therefore, they don't react very much. So noble gases, we don't associate with forming any bonding at all. Typically, therefore, we don't consider them as non-metals, even though they are non-metals, because these are the ones that form bonds. This doesn't form bond because of this particular reason. Vertical columns, so going up and down. So vertical is going up and down, and horizontal is going across. All right, so up and down refers to, well, up and down vertical. That are what you call groups, and the horizontal rows are what you call periods. So first row of the periodic table we'll call period 1. Second row from lithium to neon will be called period 2. From sodium to argon, there's your third row, is called period 3. Group 1 would be like lithium, sodium, potassium, etc., etc. That is called group 1. Group 2 will be like beryllium, magnesium, and then calcium, etc., etc. For that 4 marks, you really should be scoring that if you know your periodic table. In the next question, so these are just arrangement of electrons, basically how the electrons are arranged. They can use the term configuration or some other terms. Looking at these, you can tell this is first shell and this is second shell. As you know, if you only fill up to second shell, so this is called period 2 element, because you go across, you only fill up to second shell. And your outermost electrons is only 1, because the first shell is fully filled, and the outermost shell, meaning the valence shell, is only 1 electrons. Therefore, you can call it group 1, period 2, because there are 2 shells being filled. As for this one, this must be group 5, but period 2. This one must be group 8, and also period 2. So if I just write period number on top here, this is 2 shells being occupied, so it's period 2, second row. Second row of the periodic table, because it fills 2 shells, so fill up to 2 circles or 2 shells, period 2. This one fills up to first, second, and third shell, so this must be period 3. And then we have 1 electrons in the outer shell, so there's group 1, this is group 3, this is group 7, and this is first, second, and third shell, first, second, and third shell, so it's period 3 and period 3. Now we gotta use the letters because that's what the instructions say. You can use it once, more than once, or not at all. Which one has a proton number 17? Element consists of atoms, and when you have atoms, we know that number of protons equal to number of electrons. These are electronic configurations, so the sum of the electrons, there are 2 plus 1, there are 3 electrons, 2 plus 5 is 7 electrons, 2 plus 8 is 10 electrons, 2 plus 8 plus 1 is 11 electrons, etc., etc. We're looking for the sum where the sum of electrons equal to 17. that will be equal to the proton number, because for element which contain only one type of atoms, the number of protons equal to number of electrons. That's why the answer there must be Z, because 2 plus 8 plus 7, the number of electrons, sum them up in the first shell, the second shell, and the third shell, you get 17 electrons. Number of protons equal to number of electrons. Proton number 17, 17 electrons because it's atom. In the next one, which element combines with 3 hydrogen atoms? 3 hydrogen atoms, covalent. So this is non-metal, and the fact that we want covalent compounds, we are looking for non-metal. If you look at group 1, this is group 1, so we can say group 1, 2, and 3 are what you call metals. If you are looking at group 4, 5, 6, 7, so they are your non-metals. So we are looking with to combine with hydrogen. So this is a non-metal. We want covalent, so we want to share electrons, and you share electrons between non-metal and non-metal. So what we have is cannot be the answer because it's group 1, cannot be the answer because it's group 1, cannot be the answer because it's group 3, cannot be the answer because it's fully filled already. So it must be V or it must be Z, but then it combined with 3 hydrogen atoms. This one only need to share 1 electrons. Hydrogen will share 1 electrons. If you can imagine hydrogen, the electronic configuration is in the first shell. First period, it only has 1 electron. It will share 1 electron. This one share 1 electron. If you have hydrogen and Z, you just get 1 H and 1 Z. But this thing, 3 hydrogen atoms. So we are looking at this 5 there, because 5 plus 3, so 5 need to share 3 electrons, 1 from each hydrogen. So I share 3 hydrogen, therefore I share 3 electrons. That will give me 8 electrons in the outer shell. So that's why V must be the answer there, because you want to form VH3. One of the V share 3 electrons, 1 from each of the hydrogen there. Now, which 2 elements are in the same group? Same group means same number of valence electrons. The outermost electron is the same. This is group 1, this is group 1. So we're looking at U and also X. Which element does not form an oxide? So does not bond at all. Does not form any bond. Whether it's ionic, whether it's covalent, does not form any kind of bond. We're looking at fully filled outer shell, which are the noble gases. This is 2 plus 8 is 10. So proton number 10, that is neon. But we want the letter, which is W. Last but not least, deduce the formula. You want the formula formed between Y and Z. So Y is 2 at 3, Z is 2 at 7. So Y is 2 at 3, Z is 2 at 7. This is a group 3, so we can consider it as metal. This is a group 7. This is a non-metal. So essentially we can be thinking about ionic bonding. So if I give 1 electron there, so give 1 electrons, but I need to give away 3 electrons. So I need another 2 at 7. I give another electron there. And I have another 2 at 7. I give another electron there. So altogether I give 3 electrons away. 1 to each Z, 1 to each Z, and 1 to each Z. So altogether I will have Y3 plus, because I lost 3 electrons. When I lose 3 electrons, I get Y3 plus, and then I'll get Z minus, but I need 3 of it. So altogether, my formula is going to be YZ3, where is ionic, 1 of it, and 3 of the Z minus. Moving on to the next question. So this is fill in the blank again. This is about periodic table. This is about the elements in group 1. So the group 1 metals are what you call the alkali metals as part of your metal case study. They are all in group 1 because in the outermost shell or in the valence shell, they have 1 electron. They have 1 electron in the outermost shell. For example, lithium will be 2,1, sodium will be 2,8,1, potassium will be 2,8,8,1. As you could see in the outermost shell, all of them have 1 electrons there. These elements, basically the group 1 elements, react with water to produce metal something, they will give you metal hydroxide and also hydrogen gas. If you think about it, these are your case study, your word equation. So group 1 metal, basically reactive metal, plus your water. So water is liquid, and then they'll give you group 1 metal hydroxide. These are your word equation, which you really must master. Hydrogen gas is basically H2 gas. And this reaction, vigorous means more reactive, more extreme, more reactive, as the group is descended. Descended means go down the group. Go down the group 1. As you go down the group 1, these electrons are easier to be lost because the electrons are further away from the nucleus. Only one shell, 2 shells inside, 3 shells inside. Your nucleus, which contain your protons, become less attracted to the valence electron. And since your valence electron is less attracted to the protons, it's easier to be lost. If it is easier to be lost, they become more reactive, and therefore it become more reactive, more extreme, more vigorous going down the group 1 because easier to lose your outer shell electrons. Easier to lose valence, or you can say outermost electrons. Question 9, basically this is a 6-mark question on filling in the blank again. So this is about nonmetals. So we find nonmetals on the right hand side of the periodic table. In terms of melting point, the nonmetals example, N2O2, H2, Cl2, Br2, I2, these are all your case studies. These are all, well, not all of them, but the common one. Up until there, they are gases at room temperature and pressure, which is around 25 degrees Celsius. As you know, Br2 is a liquid, and also I2 is a gas as part of your group 7 chemistry that you learn in nonmetals. In terms of melting point, they are already gases by the time they reach 25 degrees Celsius because they have low melting point. They all are simple covalent molecules. In your syllabus under structure and bonding, you can also call this simple molecular structure, and therefore you are just breaking the weak intermolecular forces. That's why they have low melting and boiling point. In terms of density, they are very light as gases, so they have low density, where density is mass over volume. They occupy a big volume, they have low mass, therefore they have low density. Forming negative ions has another name called anions. So to form negative ions, the nonmetals will gain electrons, they accept electrons, they receive electrons to form anion. And now we talk about the stability of the negative ions. Why does certain nonmetal only gain 2 electrons, only gain 3 electrons, some of them gain 1 electrons? Because to complete the outer shell, so you want the outer electron shell, or you want the valence shell in order to be filled. You can use the word filled, or you can use the word full, but just choose either one to complete the sentence. Now the next one, nonmetals combined with metals. Nonmetal with metal, you will get ionic compound. If it is nonmetal with nonmetal, then you will get covalent compound, where you share electrons for covalent and you transfer electrons from the metal to the nonmetal to form ionic compound. In the next page, this is again about metals and nonmetals. So you got to complete this table to describe. Describe means longer words. You cannot just probably use simple words. Let's see, metals, high melting and boiling point. So high melting point here. As you know, metals are mostly solid. In fact, all metals are solid except for liquid mercury. But most metals, you know, they are solid, therefore they have high melting point. Your nonmetals include your gases, your hydrogen, your O2, your Cl2, what else? Your N2, your CO2, etc., etc. Well, probably I shouldn't include CO2 because it's not an element. CO2 is a compound. These are all elements because they only contain one type of atoms. So this is law melting point. I guess if you write down law, you probably get the mark anyway. Malleability, it comes from the word called malleable. This is an adjective. This means can change shape, can change the shape. Non-metals, it's not malleable. Okay, non-metals do not change the shape easily. Metals, you can hammer. You can hammer into thin sheets. Like in the old days, you can make body armor, you can make sword, you can change the shape of the iron, which is a metal, into whatever shape you want it to. Electrical conductivity, so metals can conduct as solid, liquid, or gas. In fact, it can conduct as solid, liquid, whereas this one cannot conduct at all. So non-metal cannot conduct at all. The type of oxide, so metal oxides are mostly alkaline. So metal oxide are alkaline, or you call them basic oxide. Basically, they dissolve in water to give you an alkaline solution. So they will give alkaline pH greater than 7, whereas non-metal oxide will give you acidic oxide. Non-metal oxides are acidic oxides, and they will give you acidic solution, which pH is lesser than 7, and they love to ask you to relate that to the color of the universal indicator. On to the next question, the change in character, the elements across, so going from left to right, the elements change from being metallic, so you are metallic elements, group 1 metallic elements on the left, to non-metallic on the right. So from group 4, 5, 6, 7 onwards, they are all non-metallic elements on the right hand side. In terms of reactivity, we talked about just now group 1 metals have to lose valence electrons, and describe, they're not asking for explained, so we can say that group 1 metals become more reactive down group 1, basically descending going down the group, because down group 1 basically there is from lithium to potassium, and the reason for it is because the valence electrons are further away, so further away from the nucleus, further away from the protons, which are positively charged in the nucleus, less attracted or less tightly held by the protons. Next one, onto the physical state. Physical state, is it a solid, liquid, or gas? This is to do with melting and boiling point. If you think about F2, because these are all group 7, we call them halogens. Group 7 are called halogens. F2, Cl2, Br2, and I2. These two are gases at 25 degrees Celsius. This is a liquid at room temperature and pressure, and this is a black solid. As you could see, it becomes harder and harder, or we can say more difficult to melt and also to boil down group 2. So the trend in physical state, F2, Cl2 are gases, Br2 is liquid, I2 is solid, so therefore melting and boiling point, so basically how easy it is to melt and how easy it is to boil, increase down group 7, well, basically fluorine to iodine. In this next question, so question 11, so properties of some elements, we gotta use the letters to answer the questions. Which one is a liquid? Room temperature is 25 degrees Celsius. You think about melting point, which is solid to liquid, and boiling point, which is liquid to gas. So you're looking for 25 degrees Celsius somewhere in between. 25 degrees Celsius is below this. A is already at 25 degrees Celsius. it hasn't melted yet because the melting point is way higher than 25. So A is still a solid at 25 degrees Celsius. This thing is way too high. It is still a solid. B is still a solid at 25 degrees Celsius. 63 is higher than 25, so it hasn't melted yet, so it is still a solid. And minus 7 and minus 248 is lower than this. It has melted, but this one is minus 246, so 25 degrees Celsius, it already boiled at 25 degrees Celsius, so that is a gas, whereas 25 degrees Celsius sits in between the melting and boiling point. That is why that is a liquid, because 25 degrees Celsius is between the melting and the boiling point. So we've gotten our answer there as D. Which elements are metals, and give a reason? So this is looking at the valence electrons, the outermost shell, the one which are filled the last. So from there I can see this is group 6, this is group 3, this is group 1, this is group 7, this is group 8. From the valence electrons, the number of valence electrons. So which elements are metals? That must be C. And we're also looking at group 3, that must be B, because they say R and they also have plural. So think about it. This one is very obvious. This one is group 3. Some students might miss this one. This is actually aluminium. 2 plus 8 plus 3 is 13. The 13th element in the periodic table is aluminium. Aluminium is a well-known metal. Okay, so what can I say? B has 3 outermost, or I can use the word valence, whichever one you like, but it's to do with the electrons, so therefore group 3 element. Alright, so what is the next one? C. C has 1 outermost shell electrons. C has 1 outermost or valence electron. Therefore, it's a group 1 element. So group 1 and group 3 elements are metals. Now, which element is in group 1? So very obvious based on what we said already. So there was C, and this is a singular question, which element is. So this is about breaking down the question. The next one, very obvious also, is an inert gas. Inert means unreactive, and as you know, even the non-metals can form covalent bond with themselves, except for group 8, because fully filled outer shell, fully filled valence shell. In fact, I am wasting my time. I should really put this down there. Fully filled valence shell. Fully filled valence. If you don't like that word, you can say outermost. Just stick with one, whichever one you like. The outermost shell is completely full already, so that's why it doesn't gain, it doesn't lose, it doesn't share. This is the one which is completely full, is element E. And that's it really for this tutorial. So I've done another 4 pages, and I hope that has been useful. Don't forget to click the button on the bottom right to subscribe to the channel. There's ptet.chemistry on YouTube, and follow me at ptet.chemistry on Instagram, Facebook, and Twitter to get connected. Thank you for watching, and I'll see you in the next tutorial video.